All right, so we are looking for all of the vectors y that are orthogonal to the vector 1, 1, 0. So effectively, we need to ensure that 1, 1, 0 dot product with a, b, c is equal to 0. That will assure orthogonality for us. So doing this dot product gives us a plus b is equal to 0, or that a is equal to negative b. And if we go and look at the form of the vector y, which is a, b, c, we can make a substitution in for a, so we get negative b, b, and c. And then we can break this down and get the two vectors that we need. That would be basis vectors for that subspace. So negative 1, 1, 0 is our first vector that we need, and then c, 0, 0, 1. So we need these two vectors, negative 1, 1, 0, and 0, 0, 1. These are going to be our basis vectors for the orthogonal complement. So the original question wants us to get this vector, 3, 2, 1, as a sum of vectors from the span of this one and the span of the complement. So it's really like, if we just take the basis vector from the first span and combine into it the two basis vectors we have from the second span. So what is it, 3, 2, 1? So let's try to write 3, 2, 1 as a combination. So let's take capital A times 1, 1, 0. So that's the basis vector in the first span. And then we need capital B times the first basis vector in the orthogonal complement. And then we'll take capital C times the second vector inside the orthogonal complement. So what we want is we want 3, 2, 1 to be written in the form A minus B. We need A plus B, and we need C. So we need C to equal 1. So basically A minus B is equal to 3. We need A plus B to be equal to 2, and we need C to be equal to 1. So we get C for free. Whoops, this is equal to 3, not to C. Can we figure out what A and B have to be just by looking? So what if A was, I mean, we can't get too crazy here, so would what could A be? I guess A could be a negative. Could they both be no, they both can't be negative numbers. And I'm thinking, what could A be? 5? It can't really be that big. I guess B could be negative, so we could take, A is equal to 4. No. I don't know. I guess I'll just do a quick little solve of this. I was thinking maybe I could just figure it out mentally. 5 halves and negative a half. Okay, so I probably would not have been able to figure it out mentally. So A is equal to B plus 3. Let's sub that into A plus B should be equal to 2. So we get that B plus 3 plus a secondary B should be 2. So we have 2B plus 3 is equal to 2. Or that 2b is equal to negative 1. So yeah, b should be equal to a negative 1/2. And if b is equal to negative a half, then we can go ahead and solve for a. So a should be negative 1/2 plus 3, so 6 halves. So a should be equal to 5/2. Okay, so with that, we should now be able to write our original vector in terms of a sum of the vectors from the original span and the orthogonal complement of that span. So what did we say? We said that A has to be equal to 5 halves. So we have 5 halves times this first vector. We have negative 1/2 times the second vector. And 1 copy of the third vector. So there we go. There is our vector written as a combination of those 3 vectors.